Knowing that g is squeezed between these two values, to find the limit as x goes to 1, we just find the limit of this as x goes to 1, the limit of this as x goes to 1. Since both of them are equal to 5, then the limit of g must be the same. So the answer to part A is 5. Same argument would show that the answer to part B is 4. Now, you cannot actually use this information to figure out anything about the limit of g of x as x goes to 0.5 because these two do not have the same limit, and so g does not have to be squeezed in between them. Right here, the limit would be 4.25. Here, the limit would be 4.5. And maybe g is somewhere in between. We don't know where g is. So we cannot say what the limit of g is as x goes to 0.5 just with this information. Okay, for the second part, the strategy goes much the same way, except that here we could say that e to the anything is always positive. So we know that a lower bounding function is always 0. And I could even make this less than or equal to if we want to be on the conservative side. But the upper bound would just be where sine 1 over x is equal to 1, right? Take that maximum, that'll maximize e to the blank. So this function, here, let me say it right, it has as an upper bound xe to the 1, or just xe. Right? And so this function is bound between the lower bound and the upper bound. The limit as x goes to 0 here is 0 because it's just constant, and the limit here is also 0, so the limit of this must also be 0.